All right, let's take your answers here. Who got A? Who got B? Who got C? Who got D? Who got E? That was rough. Let's try this again. Who got D? Oh, liars. All right. Wait a minute. How's it D? Let's practice some properties of integrals here. Isn't this the integral from a to b of f of x dx plus the integral from a to b of 3 dx? Agree or disagree? So, some things you need to know for the quiz on Thursday. Properties of integrals. Do you have to memorize all of them? I wouldn't say memorize, but you need to be able to identify which ones are properties, which ones are not. That's a question on the quiz. Okay, which of the following is not necessarily true? So this is a sum and difference rule. Do you agree? There's a constant rule where if you have a constant times the integral, the constant inside the integrand, k f of x, then isn't it the constant times the integral? There's a rule for that. Okay. Is there a multiplication rule? Quick refresher. You have these written down? So this one says if the order is flipped, the integral will have the opposite sign. This one says if you integrate from a to a, it's 0 area. So this is the constant multiple one I was talking about. If you have k times f of x, and you know the area under f of x from a to b, then you can multiply that area times k. It's a scale factor. Does that make sense? Is that reasonable? Need more explanation? Is that good? All right. The next one, sum and difference. This is the one we're talking about right now. You can add integral from a to b of f of x plus or minus integral a to b of g of x. Additivity is like a to b and then b to c. Then you can add the areas together to get a to c. But do you see any multiplication of f and g? Do you see f of x times g of x from a to b is the integral of f of x times the integral of g of x? You see one of those? I don't. Do you see one that says the integral from a to b of f of x over g of x is the integral of f of x divided by the integral of g of x? I don't see one of those. Do you see what I'm saying? You need to understand which properties work, which ones don't. What about the other ones? Max-min inequality. I guess we didn't formally. This is one of the detriments of the snow days. I had you copy these down. I didn't officially go over them. So let's talk about them now, and then we'll get back to the warm-up problem. Let's say this is f. Do you agree this is the minimum value of f? Minimum height on the interval. What happens when you take a y value times a b minus a? Isn't that a rectangular area? What happens when you take the highest point on f times a b minus a? Isn't that a rectangle? All this is saying is the true area, the exact area, is somewhere between the minimum rectangular area and the maximum rectangular area. You could narrow it down if you had to. Okay? You could narrow it down. That doesn't happen very often. All right, and this one was named after some of you guys, your Y-ball team, number 7. Domination. that what's going to happen tonight? Unless are you playing anybody else in here?
I think they play after.
Again, domination.
Dedicated.
If F's graph is always above or equal to G, the area under F is always going to be more or equal to the area under G. That seems pretty logical, doesn't it? All right. Those are your properties. So back to the story. Which property did I just use here? Not additivity. I didn't go A to B, B to C. Sum and difference, right? I used the sum of F and 3. Now I'm going to break it down. What's this part? What's that area? Oh, they told me. A plus 2B. Plus? You know it's coming. Cool. It's your turn today. Grab the door. Thank you. It's usually Dom. Looks pretty comfortable. You look comfortable. Is that a bad thing? Okay. You can own your comfort. All right. What's the second part? What's the integral from A to B under 3? 3 A to B. What's the area? We're not going to use antiderivatives here. You could, but it's a rectangle. It's just a rectangle. Don't use antiderivatives. If it's a geometric shape, don't use antiderivatives. Just make it easy. Ready? 3 from A to B. What's the base? B minus A. What's the height? What's 3 times B minus A? 3B minus 3A. For a grand total of negative 2 A's plus 5 B's. Which is letter D. Did anyone have their hand up for letter D? You're like, I'm not putting that much work into a belt problem. You know who you are. Does it make sense now? Properties of integrals. These were numbers 1, 2, and 3 from the 5-3 homework. You should probably go back and refresh your memories on those. I can also read off the answers if you'd like to have any of those. Speaking of reading off the answers, last night's homework, 7, 11, 14, 15, 18. I'll read off 14. Now, did you try to use antiderivatives for 14? Be careful. Quick answer, quick check. It was average value was 1. And it said at what point on the interval does the function assume its average value? At 0 and at 2. All right. Yeah, you can still do it that way. It's a mistake, but the numbers will still work out. My fault. Thank you. All right. 14. Average value 1 over 3 times the integral from 0 to 3 of x minus 1 squared dx. Do you know an antiderivative rule for that? If you say add 1 to the exponent and divide by the new exponent, you're using the power rule. Do we use the power rule on binomials, trinomials? We don't know. Do you agree? We don't know. So what's the safe bet? Well, FOIL it out. X squared, what are you going to get? Minus 2x plus 1. So this becomes that. So we have capital, this is little f, capital F is 1/3 x cubed minus, what's the antiderivative of 2x? Plus x plus a constant. Plug in 3, plug in 0, subtract, and then multiply by 1/3. Did you get 1? Are you okay? Are you okay if I stop here? This is the antiderivative. Plug in 3 into here, plug 0 into there, subtract, and then lastly multiply by 1/3. Good? Awesome. That was 14. 18. 18 was 0. Did you read the directions on 18? It said by appealing to the geometry of the function, right? So did you notice on 18 it was the tangent graph, which hopefully you recognize? And it went from negative pi over 4 to pi over 4. What do you notice about the areas? Cancel because of the symmetry, the odd symmetry of the graph. Make sense? So you really didn't need to do any work there. You could have said 0. And the last night's homework, yeah, there was one antiderivative problem. You're going to see more on today's assignment just as we kind of completely talk about how to find area with antiderivatives and a couple different examples. Any other homework questions you'd like to see worked out? I read off the even ones. Any of them you'd like to see worked out? All right. So we left off yesterday. I left up 7th period's work, so help me out. We were on this problem, and I think I left it like this. Caden, you're pretty good at that, yeah?
I solved it on my notes.
All right. So capital F of x minus capital F of 0. This is an area question. Capital F of x is negative cosine of x plus c. Minus capital F of 0 is negative 1 plus c. Negative cosine of x plus c plus 1 minus c. Negative cosine of x plus 1. I need you all to focus. Okay? What is that? It's an area function. It's an area function. It doesn't have a name. I could call it a of x, b of x, c of x. It's an area function. Plug in x, get out a area. Now be careful. It's not any area. What are the restrictions? Well, we have the sine of t function. Okay, plug in an x. What if I plugged in this x right here? What would the area be? 0. Why? Because the area above and the area below would cancel. Because they started the integral at 0. Okay, let's test this. What is this value over here where the sine comes up from the negatives and crosses the x-axis? Ready? 0. Radians. Radians, 0. Where does sine reach its maximum value? Y. Sine's the y value. Right? Sine of pi over 2 is 1. Sine of pi. Sine of 3 pi over 2? 2 pi. You agree? If I plug in 2 pi right here, I should get an area of 0. Let's see. What's the cosine of 2 pi? Well, it's the same as the cosine of 0. 1. So negative 1 plus 1, 0. Okay? Eyes up here. What happens if I do this? What in the problem changes? Good. So can I plug in 2 pi right here? If I plug in 2 pi into here, will that give me the area from negative pi over 2 to 2 pi? No, because this area function was based on the capital F of B minus capital F of A. The capital F of A was based on starting at 0. I would need to redo the second part to get a new function that would output an area for when I start at negative pi over 2. Does that make sense? Okay. Next question. Little f, column 1. A of x, column 2. Derivative of a of x, column 3. What is the derivative of a of x? Well, what's the derivative of cosine? Negative sine. So opposite of negative sine is positive sine. Plus. So a prime of x was the same as isn't it back to where we started? Isn't it little f of not t, little f of x? Okay, that was showing you how it works. How could I show you how this works? Because I know the antiderivative of this thing. I literally took the antiderivative, plugged in b, plugged in a, subtracted, showed you the function, took the derivative of that function. Let's do it more symbolically now. I've shown you this before. I'm going to show you again. What's this part right here? Capital F of x minus capital F of a. A of x, b of x, c of x, whatever you want to call it. That's the area function. But we're taking the derivative of it. What's the derivative of capital F of x? Little f of x. And minus, what's the derivative of capital F of a? 0. Okay, so we went through all 3 stages symbolically. See if you understand. So that's negative pi to the e power. So cosecant. Man, is this glitchy today? Fire the tabs. Actually, I restarted my Chrome today. It was sad, but it needed to be done. All right, how long do you guys want to work on this? 30 seconds? 10 seconds?
0.
Easy there, Nina. Matrix.
Yeah, I got it. I got it.
Mr. Anderson. All right. What'd you get?
That with an X.
F of X minus big F of X minus big F of negative pi.
Huh. He said you're wrong. As he did this.
That one.
What do you guys think? Now accepting answers. I heard Tyler say that with an X.
Yeah.
I heard capital F of X minus capital F of negative pi to the E. Are we voting for one of those or introducing a new possibility?
Wow.
I
like that.
Do you know the antiderivative of this? I don't. It's not a power rule. It's not a polynomial, is it? So let's imagine we did. It would be capital F, whatever that antiderivative is, plug in X, plug in negative pi to the E, subtract. But then what are we doing with it? We're taking the derivative of it. So it brings us back to that guy with X's in it. Answer. Now for a little bit of a challenge question. This will be more of like section 5.4 after the quiz, but just for fun.
Oh.
Enter the matrix. Oh, you think so?
Sine squared X.
No. This is not on the quiz. Not on the quiz.
You just said we learned it after the quiz. You said it's 5.4 after the quiz. I hope it's not on the quiz.
Maybe on your quiz. Take the red pill. You get what next time. All right. I heard sine of X squared. I'm sorry, that's not correct. Any other possible answers?
Sine squared X.
Sine squared X is even farther from the correct answer.
Sine of X.
Sine of X? Okay. I don't really feel like taking an antiderivative of this. I could. Symbolically, what's this part? Capital, if we call this little f of t, wouldn't this be capital F of X squared minus capital F of negative 1 million? I don't feel like writing that many zeros. Are you with me so far? But wait. We're not stopping there. We're taking the derivative of this thing. You ready for it? What's the derivative of capital F of X squared? He's ready. He's ready for the game. He's focused. He's ready for this game. He's ready for that game. It's the derivative of the outer function, little f. Leave the inside alone. Times the derivative of the inside. 2x. That is a composite function. It's not just f of x, it's f of x squared. It's a chain rule. Ready? What's the derivative of capital F of negative 1 million? 0. This is not my answer. This tells me how to get my answer. Before it told me just write little f of x, right? In other words, that thing with an x in it. This tells me write that thing with a x squared in it with a 2x out front. Ready? 2x. What's this thing with an x squared in it? Sine of x squared. That's our answer. Chain rule. Good stuff, huh? That was bonus content. Questions? All right, so in this section, we did properties. Nope, that's not it. I'll get to that in a minute. We did properties, rules for definite integrals. Make sure you know those rules. We did antiderivatives. We did average value of a function using antiderivatives and using geometry. That was about it. Mean value theorem for antiderivatives. So one of these first slides I had, it was a AP breakdown of the content, and we are right here right now. It's Unit 6 in the AP curriculum. It's Chapter 5 in ours. All right. Integration and accumulation of change. 17 to 20% of the test. All right. So we're in the first column. Most of you are taking the AB test. So these sections are pretty important. All right, so the rest of today, tomorrow, I'm kind of putting several assignments together and giving you options here. I'm giving you not options like to do which ones, but what order you go in as you do them, I guess. So today we finished 5.3. I have a 5.3 worksheet that are released AP questions from AP Classroom that are similar to these. They're kind of challenging. Not so much those on the quiz, but still good practice. The quiz review blank, it's posted blank, like a blank version of it. So you can work on that right now. And you've got some homework to finish up from 5.3. So these are the 3 things we're working on right now. You got 15 minutes and then some of it's for homework. If you are looking to do the most relevant quiz prep right now, I probably would hold off on this worksheet till last. All right. If you want more of a challenge, start with the worksheet first. Yep, tomorrow's going to be a work day as well. Work/asking questions day. Guys, did you get an A? That's that.
I have a question
Yes.
about this.
Okay, just give me a minute.
first, and I was like, I didn't have any drip shoes.
You a double ones there?
Yeah, that one.
Me too. I wear ties a little, but this is a little fun.
Both sides more, but I'm on the black both sides.
I cannot block these.
What do you think if Tyler was to know? I would work. That's not their stuff yet. No, I can't talk about it.
God, you're good.
Tyler's being involved with the mafia. It's actually vehicular.
The boots are
Vehicular manslaughter, actually.
That's
I just heard what? I just heard. Don't think I'm joking. I'm not sure. I don't think you'd be allowed. No, I'm guilty.
Don't say that. You're gonna do the race. I should have stopped recording that.
No, it's okay, keep it on.